Hello world! A few weeks ago, okay, let's be honest. A lot of weeks ago, an old and ugly lampshade came down in the office space of my apartment. But with the light in the northern hemisphere now fading rapidly due to the approaching winter, it's time to stop living in the dark like a complete caveman and create a light fixture to
light it up.
I currently live in a rental apartment, and I think the light fixtures that came with the apartment building are as old as the building itself, so that would be from the 70s. Yeah, I know, old. It goes without saying then that those fixtures really are overdue for a needed replacement. And if that is not a perfect weekend project for us, I don't know what is. For a long time already, I have this idea in my head that, in my opinion, is a very cool looking lampshade. It consists of 3 dodecahedra hanging from the ceiling, and in each of those polyhedrons is one light. For this weekend project, we need obviously a 3D printer with your filament of choice, calipers to measure things, 3 light sockets with cables and lights, and a small screw terminal for attaching the lights to the main voltage. The first step, however, is to dust off our Fusion 360 skills and get designing. Let's build our lampshades. We're going to make a regular dodecahedron in Fusion 360. A regular dodecahedron is built up of 12 regular pentagons at an angle of 116.6 degrees. So let's start with one pentagon. Create a polygon and voila. Let's make it 115 millimeters and 5 sides. To fully constrain everything, let's make one side horizontal and finish the sketch. Now let's go to the surface menu and use the patch to make this a flat body. Voila. From now we can just copy and paste it and rotate this to form another of the patches of the dodecahedron, but this is wrong. It should rotate around this point, and now we can use it, and it's 116.6 degrees. We can either keep on copy pasting, or we can make a circular pattern around the z-axis 5 times, and that will do it for us. Then we just repeat this to form the next layer. Select this pattern, circular pattern, select the z-axis, but 5 times, and voila. Already looking very good. Now the last patch, going to just pick side 11, copy and paste, set the pivot point to the right angle here, voila, and let's rotate this up, and that will be then minus 16.6. Voila. Now it is close off, and it's a regular dodecahedron with sides of 15 centimeters. Let's stitch everything up. Every side should be green, and after stitching you will have a solid body, and we can work again in the solid body environment. Let's first see how large it is. Let's go to properties and then bounding box. 57 by 60 by 48 centimeters. That is too large for my printer, so let's take the largest number here, which is 600, and divide this by a safe number that will fit into your build volume, which in my case is 220 millimeters. So let's search for scale, and we're going to scale it by 600 divided by 220. No, we're going to do 220 by 600. Voila! Now our bounding box should be at the most 220, which is correct. We're going to make it also a shell, because we're going to print this in vase mode. So let's home into home, make it a shell of, let's say, 0.4 millimeters. Now the only thing we'll have to do is put a hole in the bottom, since the light will be installed there. In order to know how large the hole in the bottom of our design should be, we measure the diameter of the light socket screw that we want to fit through it. In my case, this is 9.5 millimeters. So let's go to the bottom side and make a hole here, right in the middle. And of 9.5 millimeters. Okie dokie. And this finishes up our dodecahedron modeling. So let's save this as lampshade and export this as an STL file. And save. Now let's just open our favorite slicer and import the model here. Voila! Let's go to print settings and say spiral vase. Yes, that's all, not a problem. And let's lower the bottom layers to 2, and then first layer is 0.1, all the other layers is 0.2. That is just fine for me. After tweaking the settings in the slicer, all we are now left to do is load up the G-code, hit print and wait. To make things more interesting, I've chosen to make my dodecahedra all in a different color, being blue, red and yellow. I envision the ceiling canopy to be a simple half sphere. This canopy has the function of hiding away where the cables enter the ceiling. To know how large it should be, I measured the hole in the ceiling, and in my case this is 7 centimeters. The canopy should be larger than that, so let's say 9 centimeters. To model this half sphere in Fusion 360, we start from a sketch of the circle of 9 centimeters. That's 90 millimeters. We also need a line going straight through the middle of this circle. Finish sketch. Don't bother that it's not constrained. To make a sphere of this circular sketch, we use the revolve command and select one of the halves of the sphere. Then we select an axis, which is that line, and now we get a 360-degree sphere, but we only need 180 to make a half sphere. Okay, now we have a solid half sphere. To make this half sphere hollow, we use the shell command. We want it to be a thin but still rigid object, so I guesstimate that 1 millimeter thickness will suffice. The only thing we need now is a hole to fit the cable through. You can measure it, but I guessed it that 9 millimeters should be enough. So let's look at the sketch. Place a hole here in the exact middle, which should be 9 millimeters in circumference and a distance to the rest of the sphere. Now we know that that hole is exactly in the center of it all. Okay, And this is our model. This is it. This is how simple it is to model a half sphere with a hole in it. Now that we have printed everything, being the dodecahedra in vase mode and our ceiling canopy in normal mode, it's time to assemble everything. Assembly starts with threading the cables through the hole that we made in the dodecahedra. The screw at the end of the light socket really makes it easy to attach the light socket to our dodecahedra. After all the light fixtures are inserted in the dodecahedra, it's time to thread the cables through the ceiling canopy, making sure that the hollow side, the inside of the circle, is facing away from the dodecahedra, since it will be like that on the ceiling. You want to really pull them through so that you have a lot of cable room now behind this. In the next step, you would pull the insulation from each and every one of the wires sticking out. Next, we identify the two wires of each and every one of the light sockets. From each of those pairs of wires, you take one and you twist those together. Then you take all the other three remaining wires and you twist those together. Now it's a good time to check your work. From each of those twisted connections, one wire should go to each and every one of the light sockets. If everything is done correctly, you can now go ahead and connect these into one end of the screw terminal. You just push it in and twist the screw until you cannot screw any further. Now we can do the other one. Push it in as far as it goes and then tighten the screw. Test if everything is in there securely by giving it a small tug and testing if it can hold its own weight. If it can hold its own weight, well, then it's time to hang it from the ceiling. To install our beloved new lampshade, we go and stand on the most precarious chair that we can find and hang it from the ceiling. But wait! First you turn off the circuit breaker. Seriously guys, don't hurt yourself. After flipping the correct circuit breaker, you can now go ahead and safely mess with electrical cables. Now that I have light again in my room, I'm actually pretty pleased with the results. Although I've heard that some are calling it childish and not suitable for an adult's room. To which I would say, yeah, you're probably right, I get why you're saying that. Maybe I should even change the video title to how to make a kid's bedroom light. But nah, let me know what you think of it. Most of all, thank you for watching. And remember, stay creative, stay curious and stay tuned for the next episode of Jacquemus Projects.